The last piece of information we need before calibrating is revolution time. This is the time it takes for the pivot to complete one full revolution. You'll use this in determining the chemical injection rate. Calculating revolution time is a two-step process. First, we must determine the circumference of the last wheel track. The formula for calculating circumference is 2 times pi times the radius. Pi is a mathematic constant, 3.14. For convenience, we have rounded pi to 2 decimal places. Using the pi function on a calculator will produce different results from those you will see on the screen. For this example, we will assume the radius is 1,250 feet. Circumference then equals 2 times 3.14 times 1,250 feet. The circumference of the last wheel track is calculated to be 7,850 feet. Travel speed of any moving system, pivot or linear, must be measured accurately. When measuring travel speed, the system should be running wet at the speed and pressure that will be used while chemigating. If the system speed is changed in any way, recalibrate. Avoid determining pivot speed at one percentage setting and mathematically calculating the pivot speeds for other settings. A number of factors are involved, but this approach introduces significant errors in travel speed. Travel speed is expressed in terms of distance and time. The measurements can be made in 2 ways. First, record the time necessary for the outer pivot tower to travel a predetermined distance, usually a minimum of 50 feet. Second, measure the distance traveled by the outer pivot tower in a pre-selected time, ordinarily a minimum of 10 minutes. The end result of either method is travel speed, expressed in feet per minute. Remember, even small measurement errors can result in significant error in the calibration process. If your field is hilly or rolling, check rotational speed at several locations in the field and use the average speed. Soil type, slope, soil compaction, and wheel track depth are among the factors that can affect travel speed. For discussion purposes, we will assume we measured travel speed of the last tower as 6.8 feet per minute at a percentage timer setting of 100%. We next divide the circumference, 7,850 feet, by the travel speed, 6.8 feet per minute, and determine that the pivot will complete one full revolution in 1,154.4 minutes. To convert the revolution time to hours, simply divide the number of minutes needed, 1,154.4, by 60, the number of minutes in an hour. The time needed to complete the revolution, therefore, is 19.2 hours, or 19 hours and 12 minutes.